Hello everyone, this video covers section 8.4, the last section of chapter A, which will be talking about hypothesis testing for sigma square, or it could be just sigma. Either way is the exact same process. And just like the last three sections, you always need to have a claim, and then you can have two alternatives that are one tail, or one that is two tails. And again, remember, this one will use alpha, this one will use alpha over 2. By the way, you have this, for the alternative we're going to use chi-square right. This one is going to use chi-square left. Remember that this is not symmetrical. And this one is going to use both chi-square right, chi-square left. You just have to be careful that for these ones, you're going to use alpha, while for this one, you're going to use alpha over 2. Okay? And as usual, you have a test statistic. So this will be the test statistic, which is very easy to compute. Probably easier than the last two sections because there is no square roots. This value is given. This is whatever the person is claiming. So this is relatively very easy to find. Like I just mentioned right now, you want to have rejection region method and p-value as before. So if we have the first case, then the rejection region is just going to be chi-square right. The second case is just going to be chi-square left. And if it is this case, it's going to be both chi-square right and chi-square left if it is two tails. For this one, the p-value is going to be the probability that chi-square is greater than chi-square star. This one is going to be the probability that chi-square is less than chi-square star. And this will be twice the probability that chi-square is greater than chi-square star or less than chi-square star, depending on what the alternative is in here. Actually, depending on these two values. Okay. And then the conclusion and summary, that's always going to be the same as before. Remember, is reject HO or fail to reject HO, and then explain. And that's it. Alright, so let's do two examples with this. Okay, the first example says the following. Mr. Ratz, a farmer in Compton, claims that the standard deviation of the watermelons is exactly. So remember, exactly is a key word to say there's going to be both or two tails. So both means the right and the left. So you're going to need the right and the left side. So therefore the claim is that sigma is equals to 60, and the alternative is going to be that sigma is not equals to 60. So this problem on the exam will say something like this too. This is a two tails test. So that's how you know you have to do this. So let's see what's the information we have here. N is 20. The sample standard deviation is 70, and alpha is 0.01. Alright, so for step 2, we need to find the test statistic, which in this case would be chi-square star. Remember that the formula is this. So let's just plug in the values. So this would be 20 minus 1 times 70 squared divided by 60 squared, which is around 25.9. All right, then in step 3, we define the rejection region. However, this time, since this is 2 tails, we need to figure out what chi square right is, and also what chi square left is. Okay. Remember, since alpha is 0.01 and this is 2 tails, alpha has to divide it by 2. So in this case, this will be 0.005. So therefore, chi square right will be chi square 0.005 with 19 degrees of freedom. Why 19? Because n is equals to 20. And the left side, remember from section 7.4, the value that goes here is whatever you need to get to 1 or 100%. So 1 minus this will give you the left side. After this, you just have to look to the table. So if we look to the chi-square table, first we want 19 degrees of freedom, which is here. And then the value for alpha is 0.005. So it's this one, 38.582. So therefore the right side is going to be 38.582. Then the left side is going to be this one, same degrees of freedom. It will be 6.844. So the left side is equals to 6.844. Then remember that you have to draw the rejection region. Okay, it is required. So you have 0. Chi square left is here. Then chi square right is here. So if you are here or here, it will be rejected. So this is the rejection region. And so is this. Remember that this one was 6.844, while this one was 38.582. Now, just like we did in the last 3 sections, what is the value for chi square star? Well, chi square star was equal to 25.59, which clearly is in the fail to reject HO region. So therefore the conclusion is going to be fail to reject HO, which means there is no evidence to reject the claim that sigma is equals to 60. And then you have to explain, and same thing as before. All right, well, what about the p-value? So for the p-value, we're going to do something very similar to what we did in section 8.2. For the p-value, you can use the table to approximate the solution just like we did before, or you can use the calculator. So let's do the table first. For the step 3, the p-value is going to be twice. Why twice? Because it's 2 tails. The probability that chi square is greater than chi square star. And the reason why we're using greater is because the standard deviation, the sample standard deviation, is greater than the population standard deviation. Otherwise, this will be less. All right, so then this is going to be 2 times whatever probability that chi square is greater than 25.9. So we look to the table where we have 19 degrees of freedom. So 25.9 is between these two. So 25.9 is somewhere here. But as you can see, this is way closer to 27 than it is to 11. So if that's the case, just pick something close to this one. And just like in the t-table, just pick 0.2. Okay, if it is here, we're going to pick 0.001, just like we did in the t-table. So in this particular case, we're going to go with 0.2, so this will be 2 times 0.2, which is equals to 0.4. And then finally, remember the last step, you compare the p-value, which is 0.4, with alpha, which is 0.05. Clearly this is greater, and that means fail to reject HO. Okay? Now, if you do the calculator, then the probability, the p-value is going to be twice the probability the chi-square is greater than 25.9. Since this is chi-square and not t and not z, we're going to do the same thing from before. Go to second variables, and then you will see a command that says chi-square CDF. So you will see that. So don't forget to multiply this times 2, so it will be 2 times that. Then the lower bound is 25.9. The upper bound is also going to be 1,000. In this case, the degrees of freedom is 19. So this is 2 times 0.13299, and it keeps going. So this is around 0.27, which again is still gonna be greater. So 0.27 is still greater than alpha, which is 0.05. So you're still gonna get the fail to reject HO. So just like in 8.2, you can do this or you can do this. It's up to you. Okay, let's do another problem. So let's say that we have the following information. The question actually is telling you already to check for this. It's telling you that the claim is that sigma is 40, and that the alternative is that sigma is greater than 40. So this will be given. They also tell you that n is 13, that the value for the sample standard deviation is 55, and let's say that alpha is 0.05. Notice that this is only a one-tailed test because it doesn't have the not equal sign. So therefore, don't forget this is a one-tailed test, which means you're going to use alpha, not alpha over 2. Alright, so for step 2, chi-square star, remember the formula is n minus 1 s squared over sigma squared. So in our case, this will be 12 times 55 squared over 40 squared, which is equals to 22.69. Alright, so then for step 3, we only need to figure out one side for the rejection region. So the rejection region is going to be only chi-square right, which would be chi-square of 0.05. You don't have to divide it by 2. And the degrees of freedom is 12. This is equals to 21.026. So then when you draw the rejection region, remember this is 0. There's no negative values here. So then chi-square right is 21.026. So this is the rejection region. Now the value for chi-square star that we just got is 22.69, which is barely there, but it's in the rejection region. So chi-square star is 22.69. So therefore the conclusion will be reject HO, which means sigma has to be more than 40. Again, let me just remind you, we've been doing this the whole chapter. If you reject this, automatically this one is true. But if you fail to reject, it doesn't mean this is true. It just means you don't have enough evidence to reject this part, okay? Because that's the whole point of this chapter. All right, what about the p-value? Remember that for the p-value method, step 1 and step 2 are the same, so you don't have to write it again. Same thing as before. Now step 3, the p-value is going to be the probability that chi-square is greater than chi-square star. Notice that we don't have to multiply by 2 because this is not 2 tails. Also remember that you had 2 choices. You can use the table or you can use the calculator. So let's do the calculator this time first. So this is going to be the probability that chi-square is greater than 22.69. If we use the calculator, this is going to be chi-square CDF. The lower bound is 22.69. The upper bound is going to be 1,000, and the degrees of freedom is 12. Why? Because the rejection is going to look like this, 22.69. So this is the lower bound, and 1,000 is the upper bound. If we apply this in the calculator, we get 0.00856, or let's say 0.009. All right, remember the point of finding the p-value is that you need to compare with the value for alpha, or here the value for alpha is 0.05. Clearly this is less, and less, remember, means reject, HO. Okay. But what about you want to use the table? If you want to use the table, for the table, remember we need to find some values to compare with, and for that we need to write the equation again first. So if we use the table, remember the p-value is going to be the probability that chi-square is greater than 22.69. Don't forget that the degrees of freedom is 12. So we look to 12 degrees of freedom is this one, and you're looking for 22.69. So 22.69 is somewhere in here. So 22.69 is somewhere there. So therefore the value that you need has to be between this one and this one, just like we did in 8.2. So all you have to do is pick up something between 25 and 50, whatever you want. So let's say the pick 0.030. That's between those two. Notice how this is very different than this, because this is the exact solution. Well, exact is a extreme word, but exact. And this one is the approximation from the table. So this is the approximation. So even though the numbers are not quite the same, when you do step 4, remember all you have to do is compare the p-value, which in this case is 0.030, with alpha, which is 0.050, and again this is less. And if the p-value is less, remember that means reject, HO. So again, it doesn't matter if you use the calculator or you use the table. If you don't have a TI 83 or 84, well, you cannot do this, but you can always do this with the table. Remember that all the tables are provided in Canvas. And that's it for section 8.4.